Hey everyone, welcome back to the channel. Have you ever felt like your AI applications are stuck in slow motion just when you need them most? As organizations bring their AI infrastructure in-house for privacy and control, scaling these models from a simple experiment to a production-grade service becomes incredibly complex and expensive. Think of traditional AI inference like a massive fulfillment center. Usually, one worker has to do everything: read the order, find the items, and pack the blocks. When 1,000 complex orders hit at once, the system grinds to a halt. This is the inference bottleneck, leading to high intra-token latency where the AI pauses through its response. But today, we're talking about LLM-D, a Kubernetes-native open-source framework designed by leaders like IBM, Red Hat, Google, and NVIDIA to turn that struggling warehouse into a high-speed automated machine. The core theory of LLM-D is serving disaggregation. Instead of one black box container doing all the work, LLM-D splits the process into two distinct phases. Prefill, the intake phase. This is the compute-heavy phase that processes your prompt into vectors and builds a key-value cache, or short-term memory. Second, Decode, the packing phase. This is the latency-sensitive phase where the model generates the response tokens one by one. This architecture is built on three primary open-source pillars: the Kubernetes, the orchestrator that manages the cluster and scales workloads; the vLLM, the high-performance engine that can achieve up to 24 times higher throughput than standard libraries; and the Inference Gateway, the smart controller that makes the routing decisions. So, how does this look in practice? Let's look at retrieval augmented generation. A RAG prompt often contains a massive document with a tiny question at the end. LLM-D detects this long prompt and routes the heavy prefill work to specialized high-memory GPUs. Another scenario is agentic workflows or multi-turn chats. Usually, every time you reply, the model has to reread the entire conversation history, which burns through GPU cycles. LLM-D uses prefix caching. It recognizes the parts of the conversation it has already processed and reuses the KV cache instead of recomputing it from scratch. Let's get technical for a second. In a live deployment on IBM Cloud Red Hat OpenShift, you'll see specific pods running models like Granite 3.38b or Llama 3.18b for specific decode. The endpoint picker acts as the head of the cluster. When a request comes in through an interface like anything LLM, the EPP checks real-time metrics like current pod load and KV cache utilization. It knows exactly which pod has the hottest cache for your specific request and routes it there for a near-instant response. If the system gets overwhelmed, it can even perform crisis management, shedding lower priority tasks to keep your mission-critical AI running smoothly. The results are staggering. By using LLM-D, you can see a 3 times improvement in P90 latency and a massive 57 times increase in time to first token response. For your organization, this means drastic cost savings. You get significantly more out of your existing GPUs. Predictable performance. You can meet strict SLOs even under heavy load. And native control. It integrates perfectly into your existing DevOps and GitOps practices. LLM-D is the future of scaling AI into enterprise. Thanks for watching, and don't forget to subscribe for more updates.